In this video, I introduce a trusted region policy optimization for policy improvement. A Markov decision process is defined as a tuple S, A, P, R, rho 0, and gamma, where S is set of states, A is set of actions, P is a transition probability distribution, R is a real-world function, rho 0 is a initial state distribution, and gamma is a discounted vector. The expected discounted cost rho of a stochastic policy pi is defined as here, where rho pi is discounted visitation frequencies, and the advantage function A pi is defined as here. V, Q, and A are explained in this figure. The difference between V and Q are one action, which is described by the advantage function A pi. For a greedy policy pi prime, the new policy pi new is updated by the previous policy set shown here. This is the current policy and this is the greedy policy, where alpha is distance between the current policy pi old and the greedy policy pi prime. Conservative policy iteration defines a surrogate function as shown here, where alpha is calculated from KL divergence of pi old and pi new. Epsilon is calculated from a maximum of the expected advantage function A pi. The surrogate function is proved to be the lower bound of the expected discounted cost rho as shown here. The CPI directly optimizes the surrogate function instead of the expected discounted cost rho. The CPI guarantees a monotonically improving sequence of policies pi I satisfies this relationship, which generates the policy pi I close to the optimal policy as the number of iterations tends to be infinity. Here is the pseudocode of CPI method. For parameterized policy pi theta, the policy improvement is guaranteed by minimize this minimum problem. This optimization problem is converted to a theoretical trusted region policy optimization as shown here, which imposes a constraint that the KL divergence is bounded at every point in the state space. However, it requires solving a large number of constraints, which is impractical. A practical solution is to use the average KL divergence over all states for the optimization as shown here, where the average KL divergence is the KL expectation of two policies pi theta old and pi theta over all states in the state space. Using the definition of L, the constraint optimization probably comes here. And this is the discounted visitation frequencies as shown here. Using this definition and use Q theta old to replace A theta old and the importance sampling estimate to replace sum over actions, the contribution of a single SN to the loss function is defined as here, where Q is the sampling distribution. The TRPO constraint optimization problem becomes this final formulation. And this is the explanation of importance sampling, which is applied to find the optimal policy pi theta asterisk. For more details, please check with these references. Thank you. Bye.